Okay, so we're going to continue our talk on soluble or solutions. The first thing is how there's three factors that affect solubility. The first is surface area. If you crush up your solute, it's going to dissolve faster than if it's in like a cube shape. So if you think about cubed sugar as opposed to the packets of sugar that are on the tables in restaurants, the cube sugar takes longer to dissolve than those packets do because the packets have it all crushed up. So there's more surface area that allows more water molecules to the solute to help it dissolve. Another way to speed up the rate at which it dissolves is by stirring. When you stir, you bring in fresh water molecules to your solute and it helps dissolve that faster. So you can stir or agitate. Agitate, remember, just means to stir, to shake, to mix up. And then finally, you can increase the temperature. So the higher the temperature, the more kinetic energy, the more the molecules are moving, the more it's going to dissolve. So make sure you know those three things. Next, we have how much solute will dissolve. We have three terms: saturated, unsaturated, and supersaturated. Saturated is the maximum amount you can dissolve. So here in our middle picture, we can see just a little bit of solute still on the bottom of the test tube. That means we've reached the maximum amount. No more is going to dissolve. If you're at a saturated solution and you keep adding more and more, it's just going to start piling up in the bottom of the test tube. If it's unsaturated, then you're under the maximum amount, which means you can dissolve more. And so that's what this one all the way to the left represents. The one on the right represents a supersaturated solution. A supersaturated solution, you forced it to dissolve more than the maximum amount. And you do that by heating the solution, making more of it dissolve, and then slowly cooling it to room temperature. I'm going to put a video on Canvas showing a supersaturated solution and then showing all that excess, all that extra stuff, all the stuff above the maximum amount coming back out. It's pretty cool to look at. All right, how do we know if the solute will dissolve in the solvent? We use like dissolves like, very technical terminology there. Like dissolves like. So polar will dissolve polar. If you have a polar solvent like water, it will dissolve polar solutes. So here in my picture, we have ammonia and we have water. Since they're both polar, they have dipole-dipole forces of attraction holding each other together. Because they're a part of F-No, they actually both have hydrogen bonding. And that's what's being shown by these green dots in between the molecules. So because they have that in common, they'll actually dissolve together and form those connections between the two different molecules. So ammonia will be attracted to water and water is attracted to ammonia. For an ionic compound, instead of intermolecular forces, they have charges in common. So polar molecules have a positive end and it can attract the negative anion. They have a negative side of the polar molecule can attract the positive cation. So you have that likeness happening with the charges. If you have a nonpolar solute or solvent, they can only dissolve nonpolar solutes because the only thing they have in common is the London dispersion force. Alcohols are special because they have a hydroxide group or a hydroxyl group on the end. So here we have ethanol. Remember, if it ends in OL, it's an alcohol. So ethanol or ethyl alcohol. Here we have a nonpolar side to the molecule, and here we have a polar side to the molecule. So that's why alcohols can dissolve both polar and nonpolars, because they have a nonpolar and a polar end to them. Now, alcohols do not dissolve ionic compounds. They can only dissolve polar and nonpolar. I'm going to include on Canvas this little TED Talk down here. It's a very interesting way of visualizing how water dissolves ionic compounds, but it doesn't dissolve nonpolar compounds like oil. So it kind of explains why water dissolves salt, NaCl, but doesn't dissolve things like oil. All right, gas solubility. If you increase pressure, you're going to increase gas solubility. You're forcing this down, so you're decreasing volume. Increase pressure, decrease volume, forces those gas molecules into your liquid. So that's why when we want to bottle carbonated beverages, we do it under pressure so we can force the carbonation into the solution. Temperature is the opposite. We want low temperature so that the molecules don't have enough energy to escape the surface of the solution. So we like to drink our carbonated beverages cold because the cold helps keep it carbonated. Warm liquids or warm carbonated beverages tend to taste flat to us because the gas has all escaped. Speaking of gases escaping, when you pop the can open, you hear the sound. That's called effervescence. Effervescence is the sudden release of a gas from a liquid. All right, solubility curve. This is a graph that shows us the maximum amount that can be dissolved at a given temperature. So the saturation point is our saturated solution. The maximum has been dissolved. The y-axis tells us the amount of solute, and it's given in grams, and the x-axis tells us the temperature. So here's an example. I'm going to move myself out of the way so we can see the full graph. In question 1 here, we have how many grams of calcium chloride can be dissolved in 100 grams of water at 20 degrees Celsius. The 100 grams of water is just referring to this particular graph. So all of this data on the graph is per 100 grams of water. So really that 100 grams of water doesn't mean anything to this question. So the first thing that I zero in on here is calcium chloride. I have a bunch of curves on the graph. I need to know which one to look at. The substance tells me that. So calcium chloride, take calcium and chlorine, cross your charges, you get CaCl2. So we're looking at this curve right here. Next, I'm focused on the other given information, which is 20 degrees Celsius. Now, temperature is our X value. So when I look at this curve, my X value is 20 degrees Celsius. What the question is asking us for is how many grams. So it's asking us for the saturated point, how much can be dissolved at 20 degrees Celsius for calcium carbonate. So we're looking for the Y value. So then we're just going to look at our graph at 20 degrees Celsius, the curve for calcium chloride, it's right about here. And we're going to read what that Y value is. So if we take the curve and we come across here, it's about 75 grams. So we can dissolve 75 grams of calcium chloride at 20 degrees Celsius. That is saturated. Okay, the next question. We have potassium chloride. So we're going to take potassium and chlorine and we're going to cross our charges and we get KCl. So here we're looking at this line right here. We have 40 grams. Grams is our Y value. We're looking for temperature, which is our X value. So we're going to focus in on 40 grams that's on our KCl line. And it's about right here. So when we see it cross 40 grams, we're going to come down and we're going to read what that X value should be. And it's about 42 degrees Celsius. All right, the third and fourth question are a little different because we're not asked to plot a point. We're asked about what is the most soluble and least soluble. So for number 3, it says 90 degrees Celsius. So I know that my my X value has to be 90 degrees Celsius. Then when it says the most soluble, most means the topmost Y value. So we want to know how much, what's the maximum amount, what substance can we dissolve the most of at 90 degrees Celsius. So we come to 90 degrees Celsius, we find the highest line at 90 degrees Celsius. Don't think about it outside of the viewpoint that they're giving you. You have to focus on what they give you. And we have KCl to Cr2O7 or potassium dichromate. Now, the question does say which salt. Salt just means it has to be an ionic compound. So we have a metal and nonmetal, so that's an ionic compound. So this is going to be our answer. If this was not a salt, we would simply move down to the next line and see if that one was a salt. If it was, that would be the answer. So you're looking for the ionic compound that dissolves the most. When it says 10 degrees Celsius, we're looking down here at this X value. Least soluble means the bottommost Y value. So we want the least soluble, we want the least amount of grams dissolved. So we focus in on the bottom line. This curve right here is for KClO3. So then we have to think, because the question says which salt, we have to think, is this an ionic compound? Potassium is a metal, ClO3, those are nonmetals. So yes, this is a salt because it's ionic. So KClO3 would be our answer. If that was not ionic, we would simply move up to the next line. Our last type of question, we are given a X value and a Y value. So we're going to plot the point, and it's right here. Then we're going to look and see what substance are we talking about. We're talking about sodium chloride. So we're going to take Na and Cl and cross our charges. And so we're looking at this light blue line right here. So what that tells me is I've dissolved more than the maximum amount because that dot is above the line. If it's above the line, then I've dissolved more than the maximum amount. And that is called supersaturated. You've dissolved more than the maximum amount. If it was saturated, the point would be on the line. And if it was unsaturated, it would be under the line. So saturated, on the line, unsaturated, under the line, and supersaturated is above the line. And then the final question there, will it precipitate? Now remember, precipitate means forming a solid. So supersaturated, since it's above the maximum amount, we can pull more solute back out, just like the video that's on Canvas under this one. It's showing you that that excess salt can be pulled out of the solution. So the answer there is yes, because there's more than the maximum amount, it will precipitate. That also means saturated will not precipitate and unsaturated does not precipitate. Only supersaturated can do that.